In this video, we're going to talk about finding the product and quotient of two complex numbers. So if we let our z sub 1 equal r sub 1 times the cosine of theta sub 1 plus the I of sine of theta sub 1, and our z sub 2 is r sub 2 times the cosine of theta sub 2 plus I times the sine of theta sub 2. So we let those be complex numbers and we multiply them. Like, it looks really scary, but it's not too bad. So if we're finding the product, we're really just multiplying our moduli, and then so we're multiplying our moduli, and we're simply just going to add our arguments. So we're multiplying our r's, and then we're adding our thetas. And when we're finding the quotient, we're doing the same thing, except instead of multiplying, we're going to divide our moduli, which are our r's, and instead of adding, we're going to subtract our arguments, which are, again, are our thetas. We're going to subtract those. So let's go ahead and look at an example together. So here we're going to find the product of these complex numbers. So it looks really hard and confusing, but you know, it's a lot easier if you stack your z's. So if we stack them, we're simply multiplying our r's, and then notice that my thetas are the same on each of the z's. So when that happens, I'm just going to add them, and it makes it a lot easier. So it's like my sine here matches my sine there, and my theta here matches my theta there. So because I'm doing the same addition, so the highlighted portion is the same, I really only have to do it one time. So what's pi over 4 plus 3 pi over 4? Now if I wanted to, in my calculator, I could simply type in 1 over 4 plus 3 over 4, and it would give me a 1. And I just remember to put my pi symbols there. So now we're going to plug our pi into our theta places. So we have 6 times the cosine of pi plus I times the sine of pi. So now we need to figure out or evaluate the cosine of pi and the sine of pi. So using the unit circle to do this, we find a cosine of pi is worth -1, and a sine of pi is worth 0. So what does that leave us with? That leaves us with 6 times -1 plus 0i. Now 0 times I is still 0, so we kind of ignore that. And that's going to leave us with 6 times -1. And 6 times -1 is -6. And that is our solution to our problem. Let's have you practice one on your own. So I want you to find the product of z sub 1 and z sub 2. So go ahead and push pause and work out the problem. And then when you're done, push play, and let's see if you were correct. So you should begin with stacking, then preparing, so you're going to multiply your r's and add each of your thetas. Now in this case, we have a 2 pi over 3 plus 11 pi over 6. So the denominators aren't common, so we kind of need to plug it in the calculator. Doing that gives us a 2/3 plus 11 over 6, which the calculator will spit out at 5 over 2, which is 5 pi over 2. So let's see. So we have 2 times 8, which is 16. Then we're plugging our theta, so we have the cosine of 5 pi over 2 plus I times the sine of 5 pi over 2. And we're getting ready to evaluate, but when we look at our unit circle, 5 pi over 2 is not on our unit circle. Don't worry. Think about what it's coterminal with. So 5 pi over 2 is actually coterminal with pi over 2. So we can rewrite this as 16 times the cosine of pi over 2 times I times the sine of pi over 2. Now we're ready to evaluate. The cosine at pi over 2 is 0, and the sine at pi over 2 is a 1. So that's going to give us 16 times 0 plus 1i. We distribute our 16. 16 times 0 is 0. And so 16 times I is 16i. And that is our solution. Let's try a division problem. So here we're going to find the quotient of our z sub 1 and our z sub 2. So we're going to begin by stacking, again, our z's. So instead of multiplying, this time we're going to be dividing our r's, and instead of adding, we're going to be subtracting our thetas. So let's go ahead and subtract our theta. So 300 minus 75 is 225, and 24 divided by 8 is 3. So we can plug that in and get 3 times the cosine of 225 degrees plus I times the sine of 225 degrees. So this is possible to do as a radian or as a degree. So now we're going to evaluate this cosine of 225, which is negative radical 2 over 2. And we're going to evaluate the sine of 225 degrees, which is negative radical 2 over 2. So we're going to plug those in. So now we get 3 times negative radical 2 over 2 plus I times negative radical 2 over 2. We distribute our 3, and that's going to give us a negative 3 times radical 2 over 2 minus 3 times radical 2 over 2 I. And that is our solution, and we're finished. So multiplying and dividing complex numbers when they're in trigonometric form doesn't have to be scary or overwhelming.